everyone, and welcome back to Sound Approach. Today we're talking power amplifiers with DJ Taylor, our in-house audio guru, head technician, installer, and all-around audio equipment whisperer. He's going to hopefully let us in on some tightly held industry secrets and give you all the gritty details about power amplifiers and what you need to know before you buy. So, let's hit that subscribe button and get into it. When we talked about making this video, I had some questions that I wanted to ask you, and you had some things that you wanted to talk about, right?
Absolutely.
Good. But before we get into that, can we break down the different types of amplifiers and when or why each may be needed for a particular setup?
I think, Trevor, that you have to start with a platform that most people understand, and that is the receiver. And the receiver comes in two forms. It's either a stereo receiver or a AV receiver, which is audio-video, set up for home theaters and things of that nature. So inside of that chassis is a power amp, a preamp, and a tuner.
Okay.
So if we extract the tuner,
Take it away,
we're left with an integrated amplifier, power and preamplifier.
Got it.
In the case of AV receivers, it would be your preprocessor and the power amplifier.
Okay.
If you split those off of the chassis, you have a power amp and you have a preamplifier.
Yeah.
So in the simplest of forms, the world started in the 40s, 30s, power amps, preamps, added tuners to that chassis format, and that's kind of where we are today.
And that gives us the receiver.
That
So it's
gives
an
us
all-in-one unit that can power your equipment.
Yes.
And push sound.
That is correct.
Okay.
So for some people, they want to have a higher quality elaboration in their home theater system. So they would buy power amp separate. They'd buy their preamp or preprocessor separate. They'd buy their tuner and all the other sources of sound separately, yes.
And then integrate them all in through those units.
Yes, but most people, that is a complicated world.
Sure.
An expensive interconnect world, and so they live with a receiver, which is everything built into one chassis box.
So if we look at like a desktop amplifier or headphone amplifier, do those work the same way? Is that the same kind of system? It's a receiver that has the power and preamp for powering headphones.
Well, Trevor, no and yes. A desktop amplifier for headphones is generally a preamplifier and an amplifier. There's nothing else there.
Yeah.
Your source would be whatever you
plug into.
Yeah, like from your desktop.
Sure.
And then, of course, your headphones.
Okay. So, but it's still pushing power to your headphones.
Still pushing power.
Still pushing signal to your headphones. So it works the same way as a power amplifier. It's just a much smaller scale.
Absolutely.
Okay.
Yes.
Okay. And there's all sorts of different kinds. You have the DACs. So desktop amplifier.
Oh, you can get so far in the weeds on all the variations of
tube amplifiers. Yeah.
It's just simplify your life.
Yeah.
Call us. I mean, really.
That's it. Knowing what you need is sometimes the hardest part.
Well, it is. And when we get phone calls, we have to ask a lot of questions to determine what their need is, whether it's a receiver.
Yeah.
I mean, if it's a single person listening to two-channel music and they have no significant other to share that with, they may not want a receiver. It may be as simple as an integrated amplifier or a preamp and an amp, and that's it.
Yeah.
And of course, your speakers. Now, many people get totally confused with the varying types of amplifier designs.
Yeah.
And I'd love to get into that in great detail, but that's a technical discussion that is very confusing.
Okay.
So most really good quality amplifiers are built with discrete transistor elements.
Yes.
The inexpensive things take all of those and mesh them into an integrated circuit chip, which is not the same level of quality at all. And then the step beyond that, which has evolved in the last few years, is what we call Class D.
Okay.
It's not a Class A, it's not a Class B, it's not a single Class A or a Class AB. It is a class by itself, and it's considered a digital amplifier.
Okay.
Now, the problem with those for most people in the affordable range is you have a car, and your car has a battery in it, and when you stick the key in and crank it over, your engine just spins up and you can drive away, correct?
Sure. Yeah.
If you were to take 12 D-cell batteries, all 1.5 volts, and glue them together, and you end up with 12 volts of power on this D-cell, can you put it in your car and make it crank the engine over?
I mean, with enough voltage, you can.
No, it's amperage, and you can't do that. It won't work. So,
it won't work.
So it's that cranking amperage you need in your car battery to make that's that extra juice. In the case of amplifiers, we have storage caps that do that. In a Class D design, some of those caps are mitigated and they're not there, and they're hoping that the musical transient performance is just an instant and has no sustainability to that energy. So a Class D amplifier would sound just fine and work just great. But the really high-end, high-quality manufacturers today, still, pretty much Class A or Class AB design. Digital is still not used as much in higher-end products.
Right. So the Class AB gives you more sustained peak power?
Absolutely. If you listen to classical music and maybe it's the organ, and the last pedal is a 32 hertz pedal note, and someone pushes that down and it just sits there and makes that frequency. Eventually, if you have a Class D amplifier, that frequency of sound is going to become weaker. In a Class AB with huge storage caps, you've got plenty of stuff in the tank to keep it there for a long period of time.
Okay. And we're going to get into a little bit further. We're going to get into the differences between peak power and continuous power and things like that. So I think this is a good segue to get into the next section. But that's a good explanation of Class D versus Class A. So Class D is more on the lower end of the spectrum. Class A is at the higher end.
And I'm happy to come back at some point in time if you want to just be technical and talk about the engineering of all of that without.
I'd love to.
It's going to bore most people.
I'd love to. Let's see what the viewers think.
Okay.
Hit a comment down below. Let us know if you want to hear the differences between Class A, Class B, Class AB, Class D, and we can dive into the technical aspects of these amplifiers. So now that we've covered the basics, let's talk about power handling next. If I'm not mistaken, DJ, this is one of your favorite topics for amplifiers, and you have insinuated to me in the past that power handling is a crucial thing to understand, but that understanding can often be confused by industry practices.
Well,
is that right?
You're absolutely right. So let's go to Costco.
Okay, let's go.
We walk into Costco. There's this huge box sitting there. It has 5 speakers and a subwoofer and a AV receiver in it.
Yeah.
And it's $400. And on the outside of that package, it says 1,000 watts. Now, let's go to soundapproach.com and we find a AV receiver, and it's $500, $100 more, and it says 40 watts per channel.
Yeah.
How can this be 1,000 with all the speakers and everything in the world with it, and this be only, well, the Costco system, as I say many times, will only produce 1,000 watts, is if you turn it on and lightning strikes at the same time, you may get that much power out of it.
Okay. So are they focusing on a peak power surge to be able to claim 1,000 watts?
Well, honestly, most of us don't know how they derive their power, but they use something other than what we use to rate products, which is RMS, root mean square.
Root mean squared, yes.
We try to stay in the world of absolute perfect purity of performance. So it's X number of watts, all channels driven into 8 ohms at the frequency response of 20 to 20,000 with total harmonic and intermodulation distortions of less than 0.05%.
Okay.
That's a industry settled standard.
That's an industry settled standard. Is that guided by federal regulations or anything, or is that something that's evolved over time?
I think it just evolved over time.
Okay.
No, the government has no input into that of any significant method. Now, if you take that specification and you rate it one channel being driven at one frequency, at 8 ohms, at 1% distortion,
you'll get a different number.
Right. If we start out with a 100-watt amplifier under pure rating standards, RMS, and we find somebody else with this other methodology of language for their power, and you read the really fine print and you do some math, you'll find out 100 watts here is real, 100 watts there is really probably 40 to 50 watts. So you're not getting everything you think you're getting.
The power that's being specified that most people would take for the decision-making ability.
Right.
They're going to use that information to make a decision on what they're purchasing.
And often, because of that, we have conversations with people that say, I blew up my speakers because whatever they have to say.
This didn't work. Yeah.
And it's not because they have too much power. It's because they have too little power and they didn't match all of their components properly.
Yeah.
So, again, a conversation with someone who understands the good, the bad, and the ugly helps focus what you're purchasing and how it interfaces with each other part of the system.
Absolutely. That makes perfect sense. And at a lower level, amplifiers are limited in the electrical energy they can output, while loudspeakers are limited in the electrical energy they can convert to sound without damaging their components. Right?
Well, that's true. But if you have a 5-watt amplifier and you're driving it into a speaker and you turn it way up in volume, the amplifier is not the cause of the speaker dying.
No.
But it is the cause of the speaker dying because you don't have enough power.
Because you don't have enough power to run the electric.
That's right.
Yes.
If you were to take that little 5-10-watt amplifier out and put a 1,000-watt amplifier there, speakers will sit there and sing all day long and be happy. So
it's important to remember that power handling goes both ways. It's not just from the amplifier to the speakers, but it's also from the speakers to the amplifier.
Yeah, it would be correct.
Yes.
Yeah.
All right. And these limits or power ratings are very important to consumers finding compatible products and comparing competitors.
Yes, and we could talk about different manufacturers that are really well known and how they conveniently lie to you because you don't know how to read the fine print. They tell you what's there, but you have to read way down into the fine print.
Now, is it buried in the understanding of the concept itself, or is it buried just in the fine print?
It's actually both.
It's both. So it's the comprehension of what these numbers mean.
Well, if you don't understand if you don't understand one channel driven, if you don't understand one frequency, have you ever listened to just one frequency?
Yes, I have. It's a tone that just buzzes in your ear.
So when you listen to music, is it one frequency?
No, it's many different frequencies.
So wouldn't you want your power rating to be rated over all the musical frequencies you listen to instead of a test tone?
Absolutely.
Well, there you go.
So having that understanding is super important. And that's the critical component here, is that consumers may lack the knowledge that they need in order to understand the power handling of both their amplifier, the power amplifier, their integrated amplifier, their receiver, whichever it is, into their speakers.
Our industry has tried to make it simple by wattage being the specification number that people make a selection on.
Is that a safe way to make a selection?
No. And yes, it's a safe way.
It's a safe way,
but
it's
if
not
you're
ideal.
No, not at all, because if you're basing it on wattage and you don't have all the other parameters, and manufacturer A is 100 watts, but again, one channel driven, 1,000 cycles, that doesn't tell you what it really does.
Okay, so
you want to know the real world.
So do you need to know things like voltage, current, temperature, all those things? Those aren't important.
No, just call us. We can compute that out like that for you.
Okay, got it.
I'm trying to encourage people to call us. You get that?
I'm definitely picking that out, but I also want people to be informed as well. I mean, voltage is the amp's power supply and limits the maximum amplitude of the waveform it can output.
Of course.
Okay. So this determines the peak momentary output power for a given load.
Yes.
It does.
But we don't want to know about peak.
We don't want to know about peak. And we're going to get into RMS, peak, and continuous in just a little bit and discuss the differences between those. We also got a graphic that we're going to put up at that time too, because that's really going to help explain these differences and how these waveforms look differently, and how peak and continuous are more straight lines versus a waveform.
Right.
So continuing on, current is the amplifier's output devices, for example, transistors or tubes within
that is correct.
Okay. And each of these have their own individual current limit, above which they can be damaged, and they can and will be damaged above a certain current limit.
There are two levels of damage. Okay. Damage to the electronics,
yes,
but more importantly, damage to the speakers, because most manufacturers put protection circuits in the electronics. When it gets out of range,
okay,
it'll shut it down.
Okay.
So they build in the protection for that.
Is that all of them, or is that
all the good ones?
All the good ones. Okay. Is that something that's displayed and specified? And
good luck finding that. Sorry.
So you just kind of have to know.
Well, fortunately for us as a company, we have a service facility, and maybe one day we'll do some stuff with that.
I'd love to do some measurements and show people direct measurements of some of these.
We can do that, but because we have a service shop, when the manufacturer says this product does this, based on printed specifications, we can plug it up to the scope, test it, and see that they've lied to us.
Or see that they told the truth.
See that they told the truth.
Yes.
It can go both ways.
Yeah. And is it an intentional lie? I think that's the bottom line. Is it an intentional lie? Because I know that power can have an impact on price.
It does. I think it's a marketing lie.
Really?
Yes.
Okay.
This is my own theory. But I think it's the marketing side of a manufacturer that wants to make their product look better. So they're going to give you a high number with low parameters for that number.
Okay.
And when they do that, you got 100 watts. Oh, yeah, I just bought a 100-watt receiver. No, you didn't. You bought a 40-watt receiver. Sorry.
Yeah. If you're running different channels.
That's correct. Yeah.
Okay. So let's move on. We've talked about voltage and current. We've talked about the transistors, the electronics inside. Temperature is also another output that amplifiers have to be concerned about, because temperature builds up within the unit itself and has to be released.
Well, temperature is the most damaging thing to electronics, period.
Period.
Not just for the electronics, but also for the speaker.
Sure.
Remember the other day we ripped apart a speaker and you looked at a voice coil?
Yes.
Well, if you send from the amplifier a distorted, non-pure signal to that speaker, it's going to cause that voice coil to heat up and find a weak spot and melt.
As it vibrates.
Yes. And melt, literally melt. Then you've blown your speaker. Well, you didn't blow your speaker because you put too much power into it. You didn't blow it because you had too much wattage. You did all of that because you didn't have enough power. Because if you had a double, triple, quadruple the power, the speaker would just sat there and sung for you.
So I'm trying to wrap my head around that in layman's terms. So not having enough power causes too much power to be pushed?
It's not too much power. It's too much distortion.
Too much distortion to be pushed.
Right.
Okay. That's more understandable. It's
Yes.
too much distortion because it's trying harder to push power to something it can't push power to.
In the test world that we have here, it's a sine wave, a very smooth sine wave. When it goes into distortion, the sine wave goes into a flat peak at the tops and the bottom. So the wave can't totally form because you don't have enough power, so it restricts. And that flattened part is where that distortion leaves your amp, goes to the speaker, generates the heat, and creates the damage.
Somehow the more technical explanation made more sense. It did. I like that. Okay, that makes perfect sense. The sine wave can't complete. It gets cut off midstream or mid-wave. And you've got just a flat, straight line.
Pure distortion.
Yeah. Okay. That makes absolutely perfect sense. So for speakers, like we just discussed, there's also this thermal and mechanical considerations for maximum power handling. The thermal aspect, not all energy is delivered to the loudspeaker, and it fries it.
Right.
Great. All right. And the temperature will build. Can this kind of a thing result in extreme damage, like an actual fire?
Oh, yes. I remember in the early days, and we're going back to the 70s, there's a little company out of Bolivar, Tennessee, beautiful box, great sounding speaker, but they had a problem. They didn't handle enough power.
Okay.
They were at the level they were built for. They sounded marvelous.
Yeah.
But they were priced where they should have been performing at a higher level.
Okay.
So if you took a 50-watt amplifier and put into that little speaker and let it sit for a few hours, you would get the tweeter flaming out in fire, burning up.
Wow.
Because that generation of heat in the voice coil. Yeah. So yes, you have to.
So that was a combination of the voice coil, but also the movement of the woofer?
And the distortion out of the amplifier. Yeah. All of that factored together. So yes, I have seen speakers literally catch on fire before.
So this is more than just matching your equipment properly. This is a safety concern as well. To make sure that stuff is matched properly.
Absolutely.
See, I didn't know that before this.
Yeah.
I didn't know it was a safety concern. I thought it was just a performance concern.
Well, we live in the performance world first.
Sure.
We have to live in the world of not only does it perform well, is it going to last long in the home?
Yeah.
And that is where your safety concept comes in.
Well, I think we've covered pretty much everything we wanted to cover today.
Okay. This has been fun.
This is fun. But as always, DJ, thank you for your input.
Absolutely.
Thank you for your insight into this fascinating subject of amplifiers. We didn't cover everything, but I think we covered the most important.
Sure.
Okay. So to sum up, we've spoken a lot today about power handling and how specifications can be misleading to consumers. Understanding this is probably one of the most important things consumers should be aware of when purchasing an amplifier or speaker for that matter. As with everything, though, it's important to do your research, and if you can, talk with an audio expert like DJ. You can give him a call. As he said, call us before you buy to make sure you're getting the relevant information needed to make the right decision. For more information and to learn more about amplifiers or our other products, please visit our website at soundapproach.com or leave a question or comment below. If you like this content, you already know what to do, my friends. Thank you for joining us today, and take care.
See you. Bye.